By the end of this video, you'll be able to backtest the strategy of buying and holding one E-mini SP500 future contract or ES contract. Along the way, you'll learn the following: subscribing to futures data, buying a future contract with a market order, rolling future contracts, using the debugger. This is strategy 1 of Carver's advanced futures trading strategies, except that we'll be using ES instead of MES, the micro version of ES, which has a shorter history. Buying and holding ES contracts is conceptually similar to buying and holding the SPY ETF. Think of buying future contracts like ordering groceries on Amazon. For instance, you can order 10 cartons of beer, each containing 4 cans at $2 per can, to be delivered to your doorstep between 8 and 10 a.m. the day after tomorrow. Amazon places a hold on your credit card, but only charges it on the day of delivery. Even if the price rises to $3 per can after the sale, you've locked in the discounted price. Once you take delivery and pay, the contract expires. However, if you decide not to take delivery, you could sell your contract to a willing buyer at the new price of $3 per can, making a profit of $40. In futures trading, traders typically close their contracts before expiration and do not make or take delivery. Their profits depend on the entry and exit prices. In futures terms, the $2 per can is the number traders are betting on. Think of a carton as a future contract, with 4 cans per carton representing a contract multiplier of 4. The notional value of a carton is $8. Similarly, if the price of an ES contract is $1,000 and the contract multiplier is 50, the notional value of one ES contract is $50,000. Unlike Amazon, which holds slightly more than the notional value of the groceries, futures brokers require only a small fraction of the notional value as margin. Unlike the SPY ETF, futures contracts have expiry dates, necessitating a process called rolling contracts. Specifically, the ES contracts expire every 3 months. To maintain exposure, we sell the current and buy a new contract before the current one expires, and then repeat this process. Throughout our backtest, we would hold multiple ES contracts, but at each moment in time, we hold only one contract. QuantConnect simulates this process by stitching historical futures and creates one continuous contract, allowing us to study the futures price as if it were one single contract. The way of stitching pieces of the futures contracts is done in a predefined manner, but QuantConnect offers customization options for this stitching process, although the default settings suffice initially. However, the continuous contract is not tradable, and we still need to handle the rolling using the real contract symbols manually. With this context, let's begin coding. The ES data is available from 2009, so I'll set June 1st, 2009 as the start date. Around that time, the adjusted price of a contract was just under 1,000. With a multiplier of 50, the notional value of one ES contract was approximately $50,000. Therefore, I'll allocate $50,000 for the backtest. For trading futures, Interactive Brokers is ideal due to its fee structure. As before, we subscribe to data using the following code. Note that instead of using add equity, we use add future. By default, this subscribes to data for the continuous future contract. Secondly, we use futures.indices.sp500 E-mini as the ticker, unlike equities tickers represented by strings like "SPY". You can find a list of supported US futures at the link I provided below. Thirdly, similar to add equity returning an equity object, the function returns a future object. to access the symbol of the continuous future contract, you can use self.future.symbol. One important note: if we had assigned the returned equity object from addEquity SPY to a variable like self.myEquity, we would then use it when placing trades. This approach is preferable to using the string representation quote SPY unquote, as we did in the previous video, because the symbol uniquely identifies the equity object, whereas the ticker may change over time, albeit infrequently. Going back to ES, we need to buy one contract at the beginning, and roll the contract when the continuous contract rolls. Let's buy the first future contract using this. Note that slice brings in new data from the previous hour at the top of each hour. Okay, now let's give it a try. It says the security with the symbol ES is marked as non-tradable. Recall that self.future.symbol represents the symbol of the continuous contract, not the symbol of the specific contract stitched into it. To access the tradable symbol at the time, use self.future.mapped instead. Okay, let's try it one more time. Okay, so the backtest ran as expected. Next, we need to roll the contracts before they expire. When the continuous contract starts using the price of the next contract, self.future.mapped will update accordingly. This event is captured as a symbol changed event, accessible through slice.symbolChangedEvents in the onData method. During backtesting, the symbol changed event occurs at midnight Eastern Time, while in live trading, it happens at 6 or 7 a.m. ET. The code loops through the only one symbol changed event and rolls the contract using two market orders. However, because of the timing of the events is not fixed between backtesting and live trading, so we'd like to schedule the rolling of the contracts during the day as Now let's run the backtest again. Excellent. The backtest now is complete. Let's quickly have a look at the orders. This is our initial order. This couple of orders are the first row of our orders, second row, and so on. Excellent. The backtest is complete. Before we conclude, I'd like to touch on debugging. While we develop our backtest based on theory or logic and run it to validate our expectations, sometimes results may not align as anticipated. In such cases, it's invaluable to track the process step by step to understand where things diverge. For instance, pinpointing exactly when a symbol changed event occurred and monitoring the state of future symbols at each stage can be crucial. By setting breaking points and running the code in debugging mode, execution halts at the designated points, allowing us to examine the value of specific variables in detail. This approach helps us precisely analyze how the variable evolves throughout the execution. Let's take one example. So I place one breakpoint here. Also, I'd like to check what happens when the symbol changed event occurred. So I place a breakpoint here as well. So now let's run the debug, which is this button. Great, now the code ran as normal, and now the code stopped at the first breakpoint. Also, this side window is open, allowing us to do some investigation. In the watch window, we can check the values of certain variables. For example, I'd like to know the time when the code stopped. So now this is showing that at this point in time, it is June 1st at 10 o'clock, New York time. Okay, let's click on continue, which will let the code run until the next breakpoint. Now this is the first time when we run into the symbol changed event. So now it is the midnight of June the 19th. So now we know that the symbol changed event indeed happened at the midnight. And also, what's the value of the old symbol and the new symbol? Let's have a look. So this is showing that this value is not defined yet. This is implying that at this time, the line of the breakpoint is not run yet. So let's click on Step Over to run here line by line. So now we can see the value of the old symbol. Alright, that's it for this video. If you have any questions or comments, feel free to leave them below. Thank you for watching and happy coding!